In this lesson, we're going to be finding domain, range, intercepts, zeros, asymptotes, and points of discontinuity of functions. So we're going to be finding vertical asymptotes for rational functions by setting the denominator equal to 0. We're going to be finding a new asymptote. We're going to be finding a slant asymptote when the degree of the numerator is larger than the degree of the denominator using longer synthetic division. We're going to be finding x-intercepts by factoring the numerator, and using vertical asymptotes to determine the domain of the function, and use the graph to find the range of the function. So let's do a little review before we begin with the new material. There we go. So we want to find the vertical asymptotes and domain for these four functions. Okay? So to find our vertical asymptote, we set our denominator equal to 0. If we set x plus 3 equal to 0, we're going to have a vertical asymptote at x equals negative 3. Okay? That means our domain is going to exclude negative 3. So we're going to have, our domain would be negative infinity to negative 3, and then negative 3 to infinity. Okay, so the next one here, we again set our denominator equal to 0. So we're going to have a vertical asymptote at x equals negative 7, because if we set x plus 7 equal to 0 and subtract 7 from both sides, x would be negative 7. So our domain is not going to include negative 7, so that would be negative infinity to negative 7, negative 7 to infinity. Okay, the next one here, again, we're just setting our denominator equal to 0. So if we set 5x plus 1 equal to 0, right, we would subtract 1 from both sides, so 5x would be would equal negative 1. Whoops, that looks like a 7. And then we would just divide both sides by 5. So x would equal negative 1/5. So our vertical asymptote is x equals negative 1/5. Our domain then is going to not include negative 1/5. So it would be negative infinity to negative 1/5. And negative 1/5 to infinity. All right, the last function there, we're going to have to factor. Normally we would factor our numerator and denominator to make sure we didn't have any repeating factors in the numerator and denominator, because if we have a factor that appears in both the numerator and denominator, we can cancel that factor out, and that would no longer be a vertical asymptote, that would be a hole. But I will tell you that this graph has no holes in it. So we will just factor the denominator. This is a difference of squares, so this would factor to square root plus square root and square root minus square root. X plus 6 times x minus 6. I'll have to write above here, we have two vertical asymptotes, one at x equals negative 6 and one at x equals positive 6. So our domain has to exclude both of those values, so that would be negative infinity to negative 6, negative 6 to 6, and then 6 to infinity. So just a little review of finding vertical asymptotes. So the vertical asymptotes of rational functions exist as vertical lines for x where the denominator equals 0 after common factors of the numerator and denominator have been canceled. The domain of rational functions includes all real numbers except where the denominator equals 0. Okay, so we take out any place our denominator would equal 0, because that would be undefined. Okay, now we're going to state the horizontal asymptotes. We're not going to find the range. We could actually find the range without a graph for the first three, but the last one we would need to see the graph to really find the range. Right? The other ones are a little bit more simple graphs, and we know that the range is not going to include the horizontal asymptote, but the last one's a little bit different. So we're just going to find the horizontal asymptotes here. Right? So the horizontal asymptotes is related to the degree of your numerator and denominator. Right? So n is the degree of the numerator, and n is the degree of the denominator. Right? So here our n would be 0 because there's no x even here, so it means we kind of have x to the 0 power. And our m would be 1 because we have x to the first power. Well, n is less than m, so that means our horizontal asymptote is going to be y equals 0. Let's look at the second one there. Again, we have no x in the numerator, so that means the degree of the numerator is 0. We have x to the first power, so the degree of the denominator is 1. And again, n is less than m. So it would be 0, except we've added this value in. So the horizontal asymptote for just this portion would have been 0. But then if we subtract 4 from the whole thing, that's going to change our horizontal asymptote to y equals -4, right? Because we have a value added in. Let's look at the third one. Here, the degree of the numerator is 1 because we have x to the first power. The degree of the denominator is 1 because we have x to the first power. So here the degree of the numerator equals the degree of the denominator, right? So now it's not going to be 0, but it's going to be the ratio of those coefficients. So our horizontal asymptote is going to be y equals 3/5, right? So this, I should actually mark this. That's our horizontal asymptote there. This is our horizontal asymptote for this one. And this is our horizontal asymptote over here. All right, let's do the last one. All right, so the degree of the numerator is 2 because we have an x squared. The degree of the denominator is also 2 because we have an x squared. So again, it's going to be the ratio of the coefficients, and this is understood to be 1. So since n equals m, our horizontal asymptote is going to be y equals 3. So just to review horizontal asymptotes, if we can move that. So the horizontal of rational functions appears with equations y equals b according to the following rules. Maybe I should just move this up a little bit. Oops, then it's moving out of my box. Oh, now I think you can see it. So if the degree of the numerator is smaller than the degree of the denominator, then y equals 0, or y equals c if a value is added in. So that's the horizontal asymptotes we have for number 1, y equals 0. And then we have y equals c because we added in a value. We added in -4. If the degree of the numerator is equal to the degree of the denominator, right, then our horizontal asymptote is going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. Right? And so these are things we had been working on for a while now, finding vertical and horizontal asymptotes of different rational functions. Right? But now we're going to be going on to some new material. Oblique are also known as slant asymptotes. I'm going to end this podcast and I'm going to pick up and we'll learn about slant asymptotes. See you in the next podcast.